What's going on, folks? Just give me a second. I'm going to start up the next archive. I'm going to archive from 2 different computers, and that way if I don't get one of them, I'll get the other one. But can you see my computer screen all right? Can you hear my voice? All right, cool. All right. What I'm going to do today, my plan for today is I'm going to go over the homework that was due on Friday. You have another homework set that's due today. And then I'm going to pretty much finish off the rest of Quad 1 and finish all of our conversations about that. We cool? So my question to you is, do you guys have any questions about like how do you have any questions? Did you finish the homework? Was it easy? Was it hard? Do you have any questions about the homework? I was confused about this topic and all of that kind of stuff, or what? It's pretty chill. All right. Now, Brandy, you printed out another sheet, another set, right? And then you redid the last part. All right, cool. All right, let me just go grab a Kleenex, and I'll start in just a second. All right, let's do this. Okay. Dangling by a thread. No, I don't want that. I want to start the. You know what? I'm not going to start the second snag it because snag it on the PC scene does not really want to work. Anyway, this might be the best way to go. All right, so check this out, folks. We're going to cover. I'm gonna go over do some review stuff and see how you guys handled with this. My computer is slightly frozen. Let's get this thing a little bit started up. Here's what I noticed a lot on your homework. Is when I was correcting your homework, some of you guys got it. Like you guys got it. Some of you guys messed up you guys consistently messed up on the same kind of problem. So I'm going to solve out one for you completely, and I'll show you guys where you made a lot of your mistakes, so that way you guys can understand like what's going on. We cool? All right. So check this out. And by the way, I'm asking are we cool, or I mean. Nod your head, and obviously you can't nod your head, so just type in cool and we're good. All right, so you can't, a lot of you guys tried just reading it straight off. You guys just feel like, all right, what is the slope? Oh, it's 7. Oh, what is the intercept? Oh, it's 35, or something like that. You guys just thought, oh, I could just read it off. And you can't read it off unless it's in a specific form. And that specific form that we have is called the slope-intercept form, which is of the form y equals mx plus b. Forgot the plus sign there, right? So the m is your slope and the b is your thing, but before you can't tell me what the slope or the intercept is in this form until you get it into this form. We cool? Yes, I understand. No, I didn't understand that. Good. All right. So let me put this equation into that form, and I have 7x plus 8y equals 35. All right, we talked about terms, and so we have 2 terms on the left side. There's the 8x or the 7x and the 8y. The 7x term is the one we want to get rid of because it doesn't have a y in it. We want the y all by itself. So I subtract 7x from both sides. I'm going to go through this pretty quickly, so let me know if you guys get confused. And I'm left with, these guys kill each other, and I'm left with 8y equals 35 minus 7x. Come on, computer. There we go. 8y equals 35 minus 7x. Now, there's only one term left on the left side, but it has an 8 attached to it. I want the y all by itself, so I'm going to divide both sides by 8. I end up dividing this by 8, divide this by 8, and divide that by 8. So I end up getting, write this down, especially you, Jonathan, because I just took a look at your homework and it was wrong. But 35 over 8 minus 7x over 8. Or, maybe more appropriately, let's write it as y equals negative 7/8 x plus 35 over 8. These are the same thing, I just switched them around a little bit. And when I switch them around, make sure you keep that negative with the 7/8. Yes? Yes? By the way, my thumb is double jointed, so when I say yes, sometimes it goes like this, it gets weird. Don't freak out. My thumb's not broken, it's just double jointed. Good? Alright. So check this out, and here's, okay, so a lot of you guys got the slope. You guys said, alright, the slope is negative 7/8. A lot of you put negative 7/8 x, and that's not correct. It's actually just the negative 7/8. It's the stuff in front of the, x. Cool? Now, when you ask for the coordinates, here's what a lot of you did, and this is what you guys did wrong, and I was like, that's the one that's going to burn you a little bit. You know this 35 over 8? That is the b coordinate of the y-intercept. If we're talking about a y-intercept, all right, what is 35 over 8? Let's see. 8 times 8 is 16, 32. So it's like 4. It's just a little bit bigger than 4, right? It's 4.2 something or whatever, right? So my y-intercept would be here. Right around here. We cool? And if it's a y-intercept, what is the x-coordinate of a y-intercept? You understand what the question is? The coordinate of this point right here has 2 numbers. Exactly, Bernice. It's 0, comma, some number. What we end up calling b, and in this case, the b is 35 over 8. So if I asked you for what is the y-intercept coordinates, you would have to put 0, comma, 35 over 8. There were a few of you who did, okay, maybe this is 35 and this is 8. No, that's totally wrong. Nope. This number is all on the right-hand side. It's all the second coordinate number. That's the entire thing is the second coordinate number. You don't split it up. You don't do some kind of funky thing because it's talking about a y-intercept. If you're talking about a y-intercept, it has to be that x equals 0. Yes? No? Meh? What's your thoughts? Good. Good, good, good. All right, cool. Now, if you got it wrong, don't worry about it. Because at least you turned in your homework. And here's the thing that makes Mr. Dalday like super cool. The thing that makes Mr. Dalday slightly suck is I don't really accept late homework. Except for this first one, since I wanted to make sure everyone had the ability to scan or take pictures or whatever, then I accepted late homework, and so I accepted it all the way up until midnight yesterday. But I think that might be the only time I'm going to do that. All right? Unless you guys are emailing me and saying, hey, can I have an extension or whatever, you need to at least turn in something. You always should turn in something, even if it's a blank page with like notes about what you're confused on. Cool? Because so that's the thing that makes Mr. Dalday kind of suck, is that I don't accept late homework. But what makes Mr. Dalday super cool is that you have every opportunity now to go back into your homework, change your answers, resend that in, and email me and say, Mr. Dalday, I changed my answers. Can you regrade my homework? And I'll go in and I'll grade it and give you the better grade. You like that? Yeah? Okay. Now, keep in mind that the grade book doesn't show me when you change something. I have no idea. When I look at the grade book, I say, I don't know whether or not you turned in something different. I only look at I only grade things when they were due. But I won't be able to go in and say, I won't see it as an attachment. So what I need you to do is I still need you to put it in the Dropbox. I think I even gave you the option to be able to like delete stuff from the Dropbox and put in another thing. So just call it like second try or something like that. And you need to email me, hey, Mr. Dalday, I put something in the Dropbox and I changed it. Can you go in and do that? Because even if you put something new in the Dropbox and it's a Dropbox that I already graded, I won't look at it. It's not that I refuse to, it's just there's so many I have to check on that I won't go back to old ones and check on them. And unless you tell me specifically, Mr. Dalday, I put something back there, can you regrade that for me? And I would be like, of course I can. In fact, as soon as I get the email, I regrade it, as soon as I do that. And then I'll send something back and say, done, graded, or whatever. Okay? So if you want to do if you want to redo one of your assignments, it's your responsibility to tell me that you redid it and make sure that I checked it. Because it's my responsibility to grade it the first time. I'll do that. But it's your responsibility to make sure I regraded your assignments if you want to change your grade. We cool? Can I move on? And I would prefer not having email attachments. The reason being is because I want something in the Dropbox because that's what they told me. That's where they're going to go in and check my assignments to see if things are in the Dropbox. And they're not going to check my email attachments. So if at all possible, put it inside of the Dropbox. But I mean, hey, if there comes down to a point where you're getting so frustrated because this is like your 10th try putting it in the Dropbox and the darn Dropbox is too small for you to transfer that file, by all means, email it to me. Say, hey, Mr. Dalday, I'm having trouble uploading this. Can you just grade it straight from this email? I'll be like, of course I can. All right, I consider myself a reasonable teacher. All right, to me, that was the major mistakes that I saw from that homework assignment. I'm going to move on to new material then, if that's all right with you guys. So let's see what we finished covering. All right, so we talked a little bit about multiplying these things, these binomials to get a quadratic thing. Yeah? All right, I think the only thing we're going to add in now is, add to that mix is how to multiply, I hate it when my computer says not responding. I hate how slow this thing is, it's just killing me. How to take into account negative numbers into this game. And then after that, we're going to graph a few quadratic functions, and then after that we'll be good. I wonder if I need to just shut down my internet browser. Give me a second, folks. I'm sorry. I'm also having not too good of a day. My cold is really kicking my butt. But I force myself to come in because I just think that it's good that I come in and work with you guys. But I'm not feeling that great. Dude, just close the window, man. Alright, whatever, let's just move on. Sorry. Computer's freezing up. See how it says not responding on the top? I apologize. It'll work, you just gotta give it a second. Oh no. Oh, there we go. Dude. Alright. Someone is saying, one of you guys is saying, I don't really understand how to do this. What are you talking about? You don't understand how to do what? What we covered last time or this new stuff? And by the way, okay, what we covered last time. All right, I'll tell you what. Why don't I do this then? Why don't I do a little review of what we covered last time, and we'll kind of talk about what, like how to do some of your homework, and then we'll get into the new stuff Hopefully we can finish it all off in the timely manner. And by the way, somebody messaged me privately and said, I don't really understand what's going on, Mr. Dolday. Can you help me out? And you see how not everyone was able to see that, but the person who messaged me privately was able to see that on their own. What I'd like for you guys to do is be able to feel comfortable enough to know that if you ask a question, and even if you share it with everyone, they're not going to think that you're stupid. All right, let's make that agreement with everybody. Everyone, why don't we agree that if somebody asks a question, and even if we think it's a dumb question, you don't think that that person is stupid. Because what I want you to do is always ask me questions. The whole point of me being your teacher is so that you can ask me questions. If you'd rather not ask questions, then why don't I just send you off to Khan Academy and have them teach you where you can ask questions. The whole point of having me in as a teacher is to ask questions. So we can start off with you messaging me privately, and I won't point you out and I won't say, oh, blah, 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 ask me a question, and look how dumb that question was. No, I'll never do that. But what I'll do is I'll read your question, I'll try to process it, and I'll understand it, and then we'll try to answer this as best as we can. We cool? So feel free to ask me questions. This ability to ask private questions is really nice because, that way you don't have to be the person who's asking the question and slowing the class down. Because it's not. Really what it's doing is it's helping us all out. All right, I think the idea was, and this is actually really good because I'm gonna review maybe one of these example problems, and then I'll do one of the homework problems. I think maybe this one looks pretty good. This one looks even confusing. All right, let's do it. So instead of busting out the algebra tiles, I'm really just going to, I'll just draw it up here. All right. Now, if you're confused, print out those algebra tiles on page 11 of your handout and cut them out and start actually putting it up like how I'm drawing it on the page. All right. But I'm going to redo this example problem for you, and this is a review of what we did the last time. Because this will be a nice warm-up for me to get into what I'm going to be talking about. All right. So this still isn't new material, this is old material. But anyway, here's what we got to do. We have to multiply x plus 1 times x plus 2. Some of you guys learned this as the FOIL method, which is perfectly fine. You want to use the FOIL method? That's perfect. I'm going to take a little bit more remedial approach with you and do what I call it's like the tile method. And it's really what it is. It's helping you visualize what's going on and how to kind of approach the problem like this. So this is what the problem we want to do. X plus 1 times x plus 2. I want you guys to write this down in your notes. Take out a piece of paper and write it in your notes if you need to. All right, let's do this. I have an X tile, got it? And I'm going to write 1X tile over here. Are we cool with that? Yeah? Because this is the X plus 1. All right, now on the top, I'm going to write the X plus 2. So this would be an X tile, and this will be a 1's tile, and this would be a, oh, I'm sorry. I should erase this over here. That's just a 1's, and this would be a 2 right here. So this is x plus 2 on top, this is x plus 1 on the bottom. Good? Sorry, I messed that up a little bit the first time. All right. Now, what I'm going to do is when I multiply these guys together, I'm going to make sure, essentially what you need to do is when you multiply, you want to make sure that everyone in this, I look at them as like houses. Everyone in this house wants to meet everyone in this house. So, we got the x times the x. What is x times x? X squared, exactly. So that would be x squared. Got it? All right. Now, the next how we're going to do is this one right here. So we have the x times 2. What is x times 2? 2x, exactly. Which is different from x squared. Okay. Now, for this one, we have the x times 1, or 1 times x. It doesn't really matter because those are interchangeable. X times 1, 1 times x. What is that? It's 1x, or as Jonathan is saying, it's just straight up x. Because if it's 1 times x, it's really just x. Right? We're so lazy, we just write down x. All right. And then the last one is 1 times 2. That would be this box right here. And I see that somebody likes taking pictures of their screen, and that's totally fine. All right, 1 times 2, which is simply 2. All right, so in these boxes, I think they want me to put x squared, 2x, x, and 2. So this times this is all of these added together. So this is x squared, 2x, x, and 2. Now, if I want to add up all of these, it would be like adding 1 orange plus 2 apples plus another apple plus 2 papayas. What is that equal to? 1 orange plus 2 apples plus another apple plus 1 papaya is a very good smoothie if you mix it all together. We're not mixing them together, dude. I'm not talking about like making a Vitamix blenders and stuff. Exactly, Kimilani, that's perfect. You add the apples together, but you keep the papayas and the oranges and the apples all separate. So if they're same, so really what this ends up becoming is x squared plus 3x plus 2. Are we cool? Now maybe you learn this as FOIL. Maybe you learn this as x plus 1 times x plus 2. Have you learned FOIL? Yes, you have? All right, what does FOIL stand for then? Okay. Let me show you FOIL. For those of you who have seen it before, this is review. For those of you who have no idea, have never seen it before, don't worry about it. I'm not requiring that you know FOIL just yet. I think we're going to start teaching it in a second, but here's the idea. FOIL stands for, all right, there's positions in this thing when you're multiplying 2 binomials together. And what you want to do is FOIL stands for first, outer, inner, last. So what it's telling you to do is multiply the first together. Now the first is the x and the x. What is the first one of each of those binomials? It's the x and the x. Are we cool? So that's x squared. Yeah? Good? Good? All right. Now, the outers is which two? Which two are we multiplying together if I'm multiplying the outside ones? Which two numbers am I multiplying together? The 2, okay, no, not the 2 and the 1. Those are both the last ones. No, what I'm talking about is the outside ones. We're talking about this one and this one, the ones on the outside. So it's the x and the 2. So that would be 2x. Does that make sense? That would be the outers, the ones on the outside. You guys see it? Now, if you understand that, then tell me what is the inners? Which two numbers am I multiplying the inners by? The 1 and the x, exactly. So that would just be x. And then the last numbers. So if the first numbers were the x and the x, the last numbers would be the ones on the right side of each binomial. So that would be the 1 and the 2. So that would be 2. So that's what FOIL stands for, is first, outer, inner, last. And that's essentially the same thing as this. And then you end up getting, oh, okay, that's x squared plus 3x plus 2. Are we cool? So to be honest with you, when I first learned this, I learned it as FOIL. First, outer, inner, last. But I kind of like the approach we're taking it with you, where we're teaching you about these tiles. And even though it's a pain in the butt to draw these tiles every single time, it's good to start with that. Eventually, you're going to end up doing it in your head. Hopefully that's the case, where you end up just doing the stuff in your head. But before I just pull out this cockamamie thing about like, oh, you do FOIL on it, you multiply first, outer, inner, last, blah, blah, blah. What I really want you to do is just kind of experience it. And have you guys noticed that that's kind of my approach to teaching you guys, is really just having you do a bunch of work and then you telling me what you think about it. And eventually that will train you to get your own experience with this. Because I have a question for you. In fact, I was thinking about it on my way up. Which way do you learn better? Let's talk about a video game. Do you guys play video games? Name me a video game. What video game? I know you guys are going to say Minecraft. Fallout. I have no idea what Fallout is. Anyway, is Fallout like a shooter game? Like that kind of game? Alright. So, check this out. Which would you learn, which would be a better Fallout video game player? If I told you all of the rules and how to play it, or if you just played it a bunch of times? Right, the person who just plays it, the person who practices it, and makes all the mistakes, and then dies a couple of times, and then realizes, oh, I can't do that. You know what I mean? They would be a way better player than the person who is just told the answer. So that's my thing, is I hate pulling equations out of my butt and saying, memorize this. Look, FOIL, memorize it. Don't ask me where it comes from, just memorize it. What I'd rather have you do is just play with it so much that you end up coming up with your own rules, and then let me show you how the rules that you came up with conform to what we actually do in mathematics. That's what I'm having you guys do. My goal is to get you guys to play mathematics. Anyway, for those of you who are confused, do you think that you can do this now? You think you can do the homework? Awesome. Alright, now, at any point in time, again, ask me if you have any questions, let me know. And by the way, this is not Start Monday, this is Start Wednesday. Alright, let's get started on the next one, and the next one is really doing the same stuff. The only thing we're adding is a negative number. So check this out. Let's let blue equal negative and red be positive. So this is red and blue is negative. Cool? And we're going to do it the tile style, which is kind of a pain in the butt, but hey, like I said, it's a good way to start. So, we want to do this problem right here. First question is, does this represent a quadratic function? What page is this? This is page 28. Alright. So we want to do this one. Does it represent a quadratic function, yes or no? The reason why I'm asking you is because I want you guys to get used to seeing what is a quadratic function, what's not a quadratic function. So I'm asking a yes or no question. Does this represent a quadratic function? All the answer I got is okay. Yes, no. Come on, I'm not even going to burn you on who's like... I need everyone to participate here. There we go. I love the I don't know. Good. Thank you for admitting that, Jonathan. Alright. The answer is yes, it is a quadratic function, because in the end you're going to end up with those x squared terms. And remember, those x squared terms, we figured out that those aren't linear terms, those are quadratic functions. Alright, let's do the problem. We want x times x minus 2. So I have a red x, and that's my first one. And then my second one is the x minus 2, so that would be a positive x still, but a negative 2. So a blue 2. Are we cool with that?
Yeah.
Two different x's multiplying each other. Yes, exactly. Two different x's multiplying by each other. Alright, so check this out. I set up my little grid here, and it's really, I don't need that much of a grid because there's only 3 parts to it. Alright, what is positive x times positive x? What is x times x? X squared. It is still x squared. I totally agree. What is, now we're going to do the second one. So it's this column over here. This one way over here. What is positive x times negative 2? Negative 2x. I 100%ly agree. So I've got x squared and I've got negative 2x. Got it? So for part C, I'm going to write in, okay, well this is x squared and negative 2x. Well, what is this? Okay, well that's x squared minus 2x. Because the definition of subtraction is adding a negative. And that's it. That's it. That's the only wrench that I threw inside of the machine for you guys, is I added negatives into this game. Dealing with negatives, all you really got to know is a negative times a positive is a negative number. A positive times a negative number is still a negative number. What is a negative times a negative number, though? A positive number. And you guys knew that, right? That's like not something new for you, right? All right. Good.
Yeah, all
right, so let's try this. And I wrote student teacher. I think I'm going to do all of. I think, maybe what I'll do is I'll let you guys. Why don't I give you guys 5 minutes? And yeah, why don't I give you guys a 5-minute break? But in that 5-minute break, I want you to do example 2. So it's kind of a 5-minute break. Got it? And when you're doing example 2, tell me, like, I'll do the problem after 5 minutes and give you guys a chance to kind of like hack away at it. So take a look at example number 2 on page 29. You got 5 minutes. I'm going to start back at 10:09. I need to go downstairs and go get me some water. All right? I'll be right back. Are we cool with that? Try that out. See what you got. I'll be back.
There's a break. What? Thank you.
All right, I got my water. You guys got 2 more minutes. Please finish. Take your break. You got a minute now. Relax. What do you get when you split a bug into 3 parts? A dead bug. I like it. I like it a lot. Let me see. Let me tell you a funny story. A funny story. All right, when I was your age, I would go down to a fishing harbor a lot when I was a kid.
We're taking a break.
Yeah, we're taking a break. We're taking a break. I'm going to give you like a 5-minute break. Oh, well, it's 10:09, so technically I'm done with my break. But I'll tell you what. I'll save my funny story for about 20 minutes, and in 20 minutes I'll tell you a funny story. That will be our second break. Cool? All right, let's work on this problem. Can you guys hear me all right? Is the audio coming through? All right, good. So, for the first one, I have x and a -2. So that would be a blue 2 over here. And then over here, I have an x and a +3. So that would be a +3 over here. Good? All right. No jokes right now. We're going to finish off this problem. So, I set up my little grid. And according to my grid, x times x is x squared. X times +3 is 3x. I like it. Kimilani is answering the question. That's totally fine. Let's see if Kimilani's answer is correct. All right. We have, over here, we have a 2 times x, but that's a -2 times x, so that would be a -2x. Yes? Good? All right. And then the last one is -2 times +3. A negative times a positive is still a negative, and it's -6 because 2 times 3 is 6. So we have x squared, 3x, -2x, and -6. Kimilani, I think you got it correct. Ted is actually correct. You got it close. Kimilani, I think your last term got messed up. But you got close. You missed that last part. Don't worry about it. It's fine. Make your mistakes now. All right. So let's see. They want me to plug in x squared, 3x, -2x, -6. All right. What's the next step here? This is called combine like terms. All right. The combine like terms is x squared. All right. The like ones, the ones that are like, is the 3x and the negative 2x. The 6 is something different. That doesn't have an x in it. The x squared is an x squared. That guy hangs out by himself. But the 3x and the negative 2x, those are both multiplied by just 1x. And so I can combine those. What is 3x minus 2x? It's just 1x left over. So that's why I have plus x. And then the minus 2 is at the end, or the minus 6 is at the end. And that's your answer. It's x squared plus x minus 6. Which, is this quadratic or not? And the answer is yes, because it has that x squared term in front of it. Are we good? Ted, I never thought about that. I do a lot of offensive things in math, especially like segregation and whatnot. I'd say that homosexuality is offensive or whatnot, but I'm just saying that like there's some crazy funny stuff that I do in math, but yes, we put the things that are alike together. Combine like terms. All right, let's do this one. I got an x and a negative 4, so that's a blue 4. On the top, I have an x and a negative 1, so that's a blue 1. Are we good? Yes. Good? All right. So now, let's multiply them together. I'm going to put the arrows all in beforehand. That way I don't have to keep switching colors. All right, this guy's x squared. Nothing new there. What is negative 1 times x? That's just negative x. What is x times negative 4? That's negative 4x. Now here's the kicker right here. Where's the last one? What is negative 1 times negative 4? There we go. It's positive 4, because a negative times a negative is a positive number. So therefore we have x squared minus x minus 4x positive 4, x squared minus x minus 4x, positive 4. Combined like terms, it's those guys in the middle. And that would be, what is negative x minus 4x? You tell me. All right, Ted and Bernie seem to get it already. It would be negative 5x plus 4. Very good. Raimana, actually, technically, I think you're correct as well. Raimana is saying, oh, well, that's plus negative 5x. Well, the definition of a negative is x squared minus 5x plus 4. So here's the thing. And this is the beautiful thing that is nice to have someone graded by hand versus graded, the computer graded. If you were to plug this into the computer and maybe the computer wanted this, you would get it wrong. But since I'm grading it, I understand. Like, I can see, oh, I know what you're talking about. So if you give me either of these, I'd be like, that's cool. You're good. I'm done. I understand that. Check. You got the problem correct. You know what I mean? If you were to give me this, I would tell you, hey, you need to simplify that. By simplify, I mean combine the like terms. You see what I mean? All right. So, let's see. Okay. Let's do this. This is your homework, and I know that I'm doing your homework for you, but I'll tell you what, I'll do it anyway. So look at example number 1, and we have the x times x minus 2. So your homework is to recall example number 1. Look at the example I gave you. And what you want to do is, the first one is x times x, and then this was negative 2 times x. Got it? So this is x squared times negative 2x, and this is, the steps I call it is, this is called distribution. I distributed everything out. And the next thing we have is, well, this is the definition of subtraction, so this is x squared minus 2x. So the difference being is, instead of having plus negative 2x, I just put minus 2x. So that's what I mean by the steps. Explain those steps to me. First thing you need to do is, okay, I need to distribute this x into everything into here. So I distributed the x to the first one, which is why I got the x times x. I distributed the x to the second one, which is why I have the negative 2 times x. Are we cool? All right. Now for this one, it says look at example 2. And what they want you to do is, what is the first term times the first term? Okay, well that's x and x. Those are the two firsts. All right? Hey, now we're doing FOIL at this point. But see, the thing is, in the homework, I want you to discover FOIL on your own. So I'm just going to go through the first part of this and then drop off and say the rest of your homework. What is the outer times the outer term? For this problem right here. X and the 3, exactly. X and 3. What is the inner times the inner term? Negative 2 and x. I totally agree, because those are the ones on the inside. Now, we're looking at both of the last terms. That would be negative, oh, no, it's not. We're looking at the last terms. It'd be negative at, by that I think you mean negative 2, and what is the other last term? Three, exactly. So that's where we get this idea of first, outer, inner, last, which we abbreviated as FOIL. That's the whole concept. That's what's going on. Then you multiply those together, you combine like terms, you get your answer. Bada bing, bada boom, you're done. Right? So I think the rest I'm going to leave for you as homework. Page 30 and page 31. Are we cool? All right. My goal is how many more pages do we have to get to the end? I don't think we have that many. Why don't we take another, maybe a 3-minute break. And in that 3-minute break, I'll tell you a funny story. And let you have your 3-minute break. You guys can go get some food, go get some water, whatever, and do that. Page 33 and 35, yeah. So we're going to graph things, apparently. You're going to be like, oh my gosh, I don't like graphing things. All right, fine. All right, oh yeah, funny story. So when I was a kid, maybe your age, I was going over to a fishing harbor with my dad. And I saw these two guys, and they were a little older gentlemen, and they were trying to break into this truck. And I was like, yeah, I was concerned, you know, because I mean, I'm like this little 13-year-old kid looking in, and these two guys are trying to break into this truck. And I go over there and I look and I say, "What are you guys doing?" And they're like, "Oh, we're just trying to get our keys out of the car because we locked the car." And so I look inside, and inside the ignition there's these little keys hanging out of there. So I was like, "All right, cool. They're not criminals." So I go over to my dad and help him out with his boat and stuff like that. And and I tell my dad, "Hey, there's these two guys over there. They're trying to get their keys out of the car." So maybe about an hour later, I come back, and I'm working on my dad's boat with him. And I come back, and I'm walking there, and those guys are still there, and they're still at it, trying to. Now they're like taking apart a coat hanger and trying to stick it inside and do whatever, And I start I look at them, and I look at the truck, and I start laughing. And then I think they got upset at me because they're like, "What are you laughing about?" And so I said, "Do you mind if I help you?" And they're like, "Sure, you can help us. You're not going to do anything. We've been trying at this for an hour." Okay? So this is a little pickup truck. So what I did was I went into the bed of the pickup truck. I put my finger inside of the window because the back window was open just a little bit, and I pulled it open, and I went inside the truck, and I took out the keys, and I went out the door. That's my funny story. I thought it was funny. Yeah, they didn't even check the back window. I mean, come on. Come on. I mean, granted that they were probably pretty big guys, and they would need a little kid to, climb through the window and whatnot. But anyway. Thomas is like, I hate when that happens. Because, of course, that happens to you all the time, I'm sure. Oh, wait, it's 10:23. We got our 3-minute break up. All right, so check this out. Here's what I'm going to do is I think that I assigned problem set 5 as homework for you. I think that I assigned that as your homework. I'm not sure whether or not I assigned this stuff as your homework, but I'm going to go over it anyway because I think it's important to go over it, especially with the stuff we're going to be doing in the future. This is kind of a good warm-up for that. All right. So check this out. Here's what I'm going to do. I'm going to make a table of values. And have you guys learned to evaluate, if f of x is equal to x squared plus 2x minus 3, then what is f of negative 3? Well, what did I do? What did I change here? I replaced the x with what? I changed the x into a negative 3. Exactly. So I'm going to do that same thing to the right-hand side. And wherever I see an x, I'm going to plug in negative 3. And just to be careful, I'm going to put in parentheses negative 3 squared plus 2 times negative 3 minus 3. Do you understand why I make such a big deal out of the negative, or out of the parentheses? Because if I didn't have the parentheses, it would look like this. And that would be something totally different. That's the wrong answer completely. This almost looks like 2 minus 3, and so if I didn't know any better, I would subtract 2 minus 3. This looks like negative 3 squared, so I would make that negative 9, when really it's negative 3 times negative 3, which means it's positive 9. So this is totes cray wrong. Yeah, I said it like that. I have no idea what that means, but it's totally wrong. Anyway, so negative 3 times negative 3 is a positive 9. We've established that. 2 times a negative 3 is a negative 6, so that's plus negative 6. And a negative 3 and the negative 3 just kind of hangs out over there. What is 9 minus 6 minus 3? 0. Good. Perfect. All right, let's try this again, but this time, instead, using the number negative 2. Let's try that. Can you guys do it in your head, or should we do it together? We'll do this one together. I'm not going to write it all out. All right, what is f of negative 2? So if I plugged in negative 2 into here, that gives me 4. Good. If I plug in negative 2 over here, that's 2 times negative 2, which would give me negative 4. And then I still have my negative 3 left over. Do you guys catch that? So what is 4 minus 4 minus 3? Negative 3. Perfect. All right, let's do negative 1 now. F of negative 1. All right, so negative 1 squared is positive 1. 2 times negative 1 is a negative 2, and you still got the negative 3 left over. All right? So what is 1 minus 2 minus 3? Negative 4. Perfect. Let's plug in 0. What is f of 0? I love plugging in 0. 0 is like my favorite thing to plug in. Because what is 0 squared? Well, that's 0. Plus 2 times 0, 0. Minus 3. So that's just minus 3. Yes? No? Good? Bad? Ugly? Alright. Let's plug in f of 1. What is f of 1? Alright. So I'm going to plug in 1 into here, and what is 1 times 1? Well, that's just 1. And I'm going to plug in a 1 for the x over here, and that's 2 times 1, which is just 2. And then I got my minus 3, so that was 1 plus 2 minus 3 is 0. Yeah? Good. Now I'm going to plug in 2. So the number 2, f of 2. Now, 2 times 2, because that's the x squared, which is, I'm replacing the x with the 2, so it's 2 squared, which is 4. Plus 2 times another 2, which is another 4. Minus 3. What is 4 plus 4 minus 3? 5. Perfect. Now I'm going to do the last one, which is f of 3. I just take this thing slowly. Let's plug in a 3 in for the x's. 3 squared is 9, plus 2 times 3, which is 6, minus 3. What is 9 plus 6 minus 3? 12. Perfect. Is anyone confused as to how I filled out this table? And you know what I realized? I did the whole thing wrong. I'm so sorry. Mr. Dalday. What I realized is I didn't do, wait for me. I didn't even look, because part B, all it asks you to do is fill out the table for x squared. It didn't ask you to fill out the table for x squared plus 2x minus 3. Let me take a look at what's coming up and see whether or not I need to change my stance. Negative x squared. You know what? To be honest with you, I'm fine. Let's just do it like I did. I'm going to change this. Now change this inside of your thing. What I ended up doing is I said, instead of having my function be x squared, I let my function be x squared plus 2x minus 3. Let's graph that and see what that graph looks like. Shall we? And I'll tell you what, I'll make a deal with you. I'll do the other one for you. All right, let's graph that. Okay, let me go over to my graph. Here's my graph. I'm going to copy and paste my little table, what I got. And by the way, what I ended up graphing was x squared plus 2x minus 3. 3. All right. So if I have a graph, let's say it's this. You know what? I can do better than that. I can make straight lines. Here we go. There's my graph. It goes like this. All right. So let me plot points. So at x equals -3. So this is my x-axis. Here's my y-axis. At x equals -3, 1, 2, 3, I go down, or it's actually -3, 0. Right? So this first coordinate is -3, 0. Are we cool? Alright. What is this? Alright, the second point that I'm going to graph is -2, -3. So that's -2 to the left, so that's 1, 2, and then down 3. 1, 2, 3. So this is my second point right here. Yeah? Good? And then my third point is -1, -4, so that would be backwards 1 and down 4 over here. My fourth point, which is this guy right here, would be 0, -3, so it would be right here. You guys following along so far? One comma 0 tells me that the x is 1 and the y is 0, so it's here. 2, 5 says to the right 2 and up 5, so that's 1, 2, 3, 4, 5. Look at right here. And 3, 12 would be 3 out to the right and up 12, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I were to connect the dots, it would look something like that. This, my friends, is called a parabola. Exactly. Now let's talk about this parabola. It looks like a J. Yes, it does look like a J, but if I were to continue it on forever, in both directions, it looks more like a U. Exactly. So this U shape, is this like a regular looking U, or is it an upside down U? It's a regular U. All right. This is called a parabola. Now notice when it's got a regular looking U, is there a maximum Y value? You understand what that means? Is there a Y value? No, there isn't, because it goes up forever. You guys agree? Now, is there a minimum Y value? What is it? There we go. The minimum Y value for this parabola is right here. It's this point right here. It's a very special point that we call the vertex. Now for a parabola that opens up, and what I mean by that is it's a regular looking U, or the way it opens is upwards, there's a minimum value that you can talk about. And that minimum value is -4 for this specific function that we graphed. What that means is you'll never have a Y value of -5. So what I mean about that is I don't care what number you give me. If the graph looks like this, right? I don't care what X value you give me. You can give me any X value, and when I plug it in, it will never be a number that is smaller than -4. You'll never have, you'll plug in X equals, 42, and you'll have X or Y equals -6. That would never be the case. Because the minimum for this parabola is -4. It cannot be smaller than -4. Does that make sense? That's why we call it a minimum. Now, what does that mean? Did you guys learn about domain and range? A bit, okay. You should have learned a lot. Hopefully you learned a lot. But anyway, here's what I'm talking about. The domain is all of the allowed x values. The range is all of the allowed y values. Okay? The range for this parabola is any number bigger than -4, because that's all of the allowed y values. There are not allowed y values in this case, and that's any number smaller than -4. Do you guys agree? Because if you look at your parabola, you can't have your parabola going anywhere below this point right here. This is like the Badlands over here. You can't get there. Your parabola doesn't go that small. It's kind of like this, all right? Let me see if I can explain it to you this way. I'm going to look at another parabola, and this parabola I really like, because this parabola has to do a lot with physics. I want you guys to find something soft, like a piece of paper, a scratch piece of paper. You guys got it? I got this, my Kleenex. Okay? Crumple it up into a ball. Do this, I'm serious. All right? Now throw it up into the air. Try not to hit the ceiling. And it comes back down to you. All right. What that did is it made a little parabola like this. Is the tissue used? Yes, I used the tissue, so it's got a little weight to it, which is good, because that's what I want. But did you guys see the parabola that it made? Made kind of like a little parabola, right? How high did it go? How high did your tissue go? Let's guess. How's about let's say 10 feet? Okay? So let's say this went up 10 feet tall. We cool? Alright, let's pretend that it went up 10 feet. So what I'm saying here is there is a maximum point at which this thing reached. It doesn't have a minimum, it has a maximum. It definitely has a maximum though, right? And what is the maximum for this thing? It was 10 feet. Do you guys agree? But if I were to ask you a dumb question like, okay, well, when did it reach 12 feet? And you say, wait, I threw it up and it only went up to 10 feet. It will never get to 12 feet. It never reached 12 feet. Because it's going to go up, and the highest it's going to go is 10 feet, and then it's going to come back down. So asking me a question like, when does it reach 12 feet is a stupid question, really. You know what I mean? Do you guys see what I mean by range? The range for this thing is between 0 and 10 feet. It can't get any higher than that. That's unallowed. So parabolas have these things that you have to talk about where your range is. So I mean, like, yeah. So let's talk about this problem right here. My question to you is, all right, let's go through this. For our first parabola, which kind of looked like this. All right, I'll tell you what. I promised you that I would graph for you the actual example. And the actual example was not using x squared plus 2x minus 3. It was just using straight up x squared. So let me make that table for you. Okay? I'm going to do this problem, and I'll do it for you, and I won't even ask you as many questions because I ended up doing the wrong one for you. I ended up doing the one that's a little bit harder. Let me do the easy one for you. So if I have f of x equals x squared, and I plug in all of my values, so I have -3, -2, -1, 0, 1, 2, 3, and I plug that in for x, and I want to figure out what y is. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Anyone confused about how I got that table? Because I plugged it into my function, and my function is defined as x squared. So, whatever you tell me, I'll just square it. All right. If I were to graph that, then that would be at -3, you go up to 9. So somewhere around here. At -2, you go up to 4, so that would be 1, 2, 3, 4, somewhere around here. At 1, you go to 1. At 0, you go to 0. At +1, you go to 1. +2, you go to 4, and then 9. And then here's your parabola. It looks like this. Let's answer the questions about that. The shape of the graph looks like what? You can choose from these. It looks like a U. I love it. The graph of f of x squared is called a parabola, exactly. The lowest point on this function is called what? It's called the minimum. This one doesn't have a maximum because it's a regular u. If it's an upside down u, then it has a maximum. All right. The minimum point on the parabola is called the vertex. Oh, that's an EX, sorry. And the vertical line that passes through the vertex is a point that divides the parabola in half is called what? What they're talking about is, if I were to draw a line straight down this point right here, do you see how this part right here, the left-hand side of the stuff on this line, looks like the right-hand side? For this example problem, I want you to do the x squared one. I think the x squared plus 2x minus 3 is a better graph because it's more interesting. But for this example, for the answers for the example line that I'm doing, we're talking about the x squared one. But anyway, the vertical line that passes through the vertex and divides the parabola in half is called the axis of symmetry. Are we cool? That's called the axis of symmetry. And that makes sense because if I cut it down the middle, that would be symmetric. That would cut the parabola in exactly half. Yes, this WebEx is being recorded. Hopefully it's being recorded. All right. Let's do this one because I think this is really quick. Let's do this problem together. Ready? Actually, this is your challenge set, so technically I don't need to do this for you. But I'll tell you what, I'll do the table for you. I won't do the graph and everything. Complete the table of the values below. So it's negative x squared. Oh, you don't know how to check the archives and whatnot? That'd be a good thing to talk about real quick. Why don't we open up this? I'm on page 34, I think. But let me check let me go down to my class and show you. Yeah, I do archives a little differently from other classes. I'll show you why. All right. I don't have any archives that I save in WebEx, and the reason being is because WebEx doesn't give me enough room to save all of my archives. If I use the WebEx recording to do archives, what happens is I'll run out of room in about 2 weeks. And then after that, I have to start deleting archive space, which is kind of a dumb thing because, I mean, if it's archived, you should have to be able to access it all the time. So instead, what I use is a different program called Snagit, which means it's a little bit more of a pain in the butt for me to do because what I do is I record my computer screen and then I capture that and I upload it to YouTube, which I can upload as much as I want without any worries about it having not enough space. After I upload it to YouTube, I share with you guys the link, and here's where I share it, right here. So I'll put the date, so it's actually right in your class right there, boom. You can play it, you can watch it, it's a long video.
So what's going on, folks?
Obviously that's too small to see, so then you can click on this and that will bring you to the YouTube video.
So what's going on, folks? Can you see my computer screen?
And that will bring you to that. And if you want to go full screen or large screen or whatever, and also if you want to follow me, that would be cool. And if you want to up my view counts, because apparently that's a big thing, I only have 4 views on this thing, so if you would like to follow me, I think my user, my subscribe name, I have no idea, but anyway, once you see one of those, you can subscribe to it. But anyway, this is where I put the archives. I put it actually straight up in our class. So that way you know exactly what this archive is for. It's for this week coming up. And the first archive that I did, Snagit crashed. So even the system that I'm using is not perfect. All right. I have no idea what you guys are talking about. You guys are speaking a whole different YouTube language. Anyway, let's do this one. All I'm doing here is I'm doing the negative x squared. And so what I'm going to do is I'm going to plug in negative 3 into here, but I'm going to slap on a negative onto that one. So what is negative 3 squared? It's positive 9. But I slap a negative onto that positive 9, it becomes negative 9. Did I just do some crazy for you, or does that make sense? All right. Now, a negative 2 in here gives me a positive 4. But then I have to slap on this negative over here, and I get negative 4. This is negative 1. This is 0, negative 1, negative 4, and 9. Or negative 9. Yes, I did it that quickly. There's tricks that you can learn. All right. And then you can answer the rest of these questions. I'll tell you what, I know this is, I don't know if I assigned this as homework, but if this is one of your homeworks, I'll do one of the problems for you. Let's take a look at this. And then I'm going to try to finish already. I'm done. I don't think there's any more for me to cover. We're on page 36 already. But let's do this one. So right now, this quadratic function is not in quadratic form. In order to do that, what I would do is this thing called FOIL, which we've been talking about all this time. So we FOIL this, the first, outer, inner, last. The first is x times x, so this is x squared, right? The outers is the plus 2x. The inners is the negative 2x, and the last is the negative 4. You guys see that? So really, this is x squared minus 4. Oh, okay, so it looks like I do have this thing due. Or I don't. Okay, so I didn't give you guys the challenge worksheets and everything, apparently. That's fine. I'm still gonna do the problems for you anyway. Just because I know that this is what we're gonna be covering next time. So it'd be good for me to kind of introduce to you. I'll finish this off and then we're done. Alright. Where's the vertex on this sucker? It's right here. What's the coordinates of that vertex on that thing? Well, the x value is 0, and the y value is -4. So I would say 0, -4. Yeah? Is there a minimum or maximum on this kind of parabola? A minimum, exactly. List the x coordinate, or list the coordinates of the x-intercept. Oh, what it's saying is, where does this thing cross the x-axis? Right here and right here. So that looks to me like -2, 0, and +2, 0. Remember what we were talking about. If it's the y-intercept, then the x is guaranteed 0. That's the first thing I did with you guys this morning. But if I'm talking about the x-intercept, then the y value is 0. Because it's these points right here. This is the y-intercept. Oh, well, that's 0, -4. Use a different color pen to draw the axis of symmetry. It would be this line right here. That's how you do that kind of homework. But I don't even think I assigned that homework. Should I make it extra credit? I don't know. I haven't thought about that yet. Do you want it as extra credit? Page 36 through 39, I guess. You do? What is page 38 and 39? I didn't even write that down. Don't even have that on my paper. Oh, okay. Oh, okay. So, do you want 36 and 37 to be homework? Or to be like extra credit? Alright. I'll think about it, but I get to choose how many points I make the extra credit worth. Sounds good? I'm not going to make it worth like 10 points. Yeah, the homework for today says page 10 is due. Up to page 10, I think. So that we covered last time. Like a long time ago. Alright. I'll talk to you later. I have an 11 o'clock class that I got to go and teach. So we are done with talking about quadratic homework, number 1, or part 1. Now we're moving into, hey, I need to warn you guys, remember, we're going to move into talking about one new topic every week at this point. So right now we took the first 2 weeks to cover one topic. Now we're going to move into doing one topic in 1 week. So the pace is going to keep up, or is going to get faster. So let me know if you need me to slow down. Also keep in mind that we're a week and a half ahead of where we're supposed to be. So we have some time to slow down if we need to. Got it? And it's imperative that you attend class. All right. Talk to you later. You guys have fun.